3.1 lines and angles. You got to leave today being able to identify angles formed by a transversal. So we got to tell you what a transversal is. Gauge, let's parallel lines. Let's get a definition for parallel lines. Parallel lines, let's put this 2D. So two-dimensional. Two-dimensional means this: they are coplanar. They're in the same plane. Write it down. So 2D is two-dimensional, they're coplanar, and they never intersect. So what do they look like? Train tracks. They look like train tracks, but they've got, this is huge. They are coplanar. That means they're in the same plane. Okay? Now skew lines. Let me tell you the difference between skew lines and perpendicular. Skew lines are 3D. That means non-coplanar. They are not coplanar, but they never intersect. They never intersect. So how is that possible? How can two lines never intersect? They could. This is the key. It's in 3D. That means they're not on the same plane. So here we go right here. I got a line, right? So we've got a line like this. Amber. This is in this dimension right here. It's in this plane. It's in this flat screen, right? So let's say, now you got to think abstract. We're going to go 3D. Let's say I've got a point right here. So it's below this line. Now, coming out of this point is a line going this way. These lines go forever. So this one's going to go forever left and right. And this one coming out of this point is going to go forever, kind of like north and south. Will these lines ever intersect? They will never cross. They are skew lines. To be skew line, it's got to be in the third dimension. It's got to be on a different plane. So think of this floor right here. This floor is a plane. It goes forever in both directions, to the left, right, and north and south. You can have lines in this plane that go any direction. Christian, we can have a line that goes diagonal. Okay? Now you got a plane right here, the ceiling. If I have a line in the ceiling, is it going to ever cross with a line in the floor? They never will, because they're skew lines. They are actually in parallel planes. That's a picture of parallel planes. Think of this. Parallel planes, think of the floor and the ceiling. They're planes that never ever intersect. They never cross. So any line in a parallel plane is going to be a skew line. Gage, let me ask you this. Are these two planes parallel? Is the floor, think of the floor. The floor is a plane, and gauge this side wall right here. This wall is a plane. Are they parallel planes? So the floor goes forever, and this wall goes forever up and down. Are they parallel? Why not? Do they touch? Do they intersect? Do they cross? Where do they cross? They cross right there at the carpet. Good. So parallel planes. You guys got a question about skew lines? Okay, let's review two postulates. Now, next to postulates, write this. A postulate is just stating the obvious. That's all a postulate is. It just states the obvious. And sometimes it's easier to look at a picture. So let's change this English into a picture. The parallel postulate. Here's the parallel postulate. If there is a line, so let's draw a line. Everybody draw a line. If there is a line and a point not on the line. So I'm going to draw a point above it right there. So if there is a line and a point not on the line, then there is exactly one line that can go through this point and at the same time be parallel. So the criteria is it has to go through this point and it has to be parallel to this line. So it's going to look just like this, like your train tracks, like you said earlier. And this postulate says that's the only one scenario that exists. There cannot be any other line that goes through this point and at the same time is parallel. Okay, now I forgot to give you this. Symbolic notation. Everybody draw a triangle right there and a triangle right there. These are your shorthand notes. That these marks are parallel marks. So shorthand, instead of writing out this line is parallel to this line, if it ever has two triangles, that means they're parallel. Okay? Last thing, let's call this line A and let's call this line B. So I want to write shorthand for line A is parallel to line B. Here's how we do it. There's your line. So we can go line A parallel to line B. These two vertical bars, that's your shorthand for parallel. Thomas, that's how you read this. Line A is parallel to line B. You got it, Gage? Write it down. Line A is parallel to line B. That's your shorthand. Do we got any questions about the marks, the triangular marks or the vertical bar marks? Okay, the perpendicular postulate. It's kind of obvious, kind of common sense. If there is a line, so let's draw a line. And there is a point not on the line, so let's draw a point somewhere out here. Then there is only one line that can go through this point and be perpendicular to that line. And it would look something like this. Perpendicular, that means they intersect at 90 degrees.